All right, well, welcome back to day 4 of Ruby Remote Conf. Before we get started, I want to do a quick shout out to our sponsor, hired.com. If you're looking for a job or know someone else who is, have them go check them out at hired.com/Ruby Remote Conf. They have an auction where companies from San Francisco, New York, and LA bid on developers and provide them with salary and equity up front. You can choose to interview with them, or you can turn them down with without any obligations. But if you do sign up with a company through hired.com, you get a $2,000 bonus. But if you use our link, you get a $4,000 bonus. So if you're looking for a job or you know someone else who is, give them that link and have them go check it out. Our first talk is by Mike Moore. Mike is a good friend of mine. We don't live that far from each other. And he is the organizer of the Mountain West Ruby Conference. His talk is Writing Games with Ruby. And Mike, go ahead and take it away.
All right. Hello, everybody. I'm going to go ahead and switch this to QA mode. So if you have any questions, feel free to jump in. And I'm going to disable my video because it's kind of creepy to me. So I'll see you at the end when there's Q&A. I guess if it will let me, it won't let me do it. All right. So like Chuck said, this presentation is writing games with Ruby. We're going to go through how to use Ruby to make games. If you want to follow along,
your desktop or slides. Do you have slides or desktop?
I do. Now, what is going on? All right. How's that? Is that any better? So we are going to go through writing games with Ruby. If you want to follow along, gem install Gosu. Gosu is a library that we are going to be using to make the games. It's going to take care of all of the hardware access for us. So putting things to the screen, playing music, playing sounds, taking input from the user. It's all going to go through Gosu. Gosu is a wonderful little library, a very minimalistic library for taking care of all of those concerns. It's a great fit for Ruby. And if you want to follow along with the code examples, I've got all of the code that we're going to be going through up on this GitHub repo. So that's Blomage, Writing Games, Ruby Remote. You can follow along commit by commit. There's about 25 or so commits for each change that we're going to make throughout this process of writing this game. Or going through and exploring the concepts of writing games within Ruby. So pull down that repo and you can follow along, or just open up your editor and follow along with me because it'll be pretty fun. This is me. If you've maybe seen me online, this is the picture I use. My name is Mike Moore. I go by the handle Blomage. Some people call it Blomage. It doesn't really matter. It's available everywhere. So it's kind of my default handle. I do have a secret to share with you, and that secret is very, very impressive here. That writing games is totally fun, right? Mind-blowing, I know. Why do I think that writing games is so much fun? I think writing games is so much fun because I get to use Ruby. And Ruby is, by definition, super awesome fun. So like I said, we're going to use GoSoo. You can find more information about GoSoo at the libGoSoo website. That is, oh, I missed my shortcut here. That's at this website. It's written in C++, but it was written specifically for Ruby. So you can continue to use GoSoo with C++, but the object model and everything is really geared around Ruby as a first-class consumer of it. There are some games that have shipped on platforms like the iPhone, that use GoSoo with C++, but you can also just use it with first-class Ruby bindings. The documentation is right here, and we'll be taking a look at this information as we go through. So I'm going to quickly open it up to the window class, because that's the main class. We're going to get to that. Keyboard shortcuts are all messed up. All right, so installing it is really easy. It's a gem install GoSoo. You may need to sudo install it because it needs to install some system resources. If you're on Mac, you also will probably need to brew install the SDL library, specifically SDL2, because that is a dependency on modern GoSoo. If you install an older version of GoSoo, like 7.50, you'll use the SDL that ships with Mac, but you can always update SDL to SDL2 on the Mac and use the current versions of GoSoo. It's cross-platform. It runs on Linux. It runs on Windows. Like I said, it's pretty great. So what actually is possible with GoSoo? Well, GoSoo can make lots of different types of games possible. I'm going to switch over here to my console, and I'm going to go to my GoSoo install. And if you clone their Git repo, you'll see a directory that looks an awful lot like this. There's also in here, there's an examples directory. So let's go there. And if you can look at all of the example games that ship with GoSoo, they illustrate different aspects of how you work with GoSoo, from getting input, from dealing with network and OpenGL integration, all that type of stuff. The one that I'm really interested in here is Captain Ruby. So running that is really easy. It's just Ruby. I can type Captain Ruby.rb. Okay. So here you see, here's this game. If you press the up arrow, he will jump. If you go left or right, your character here will move. You can move and jump at the same time. And then you can also fall. And the controls here are pretty challenging, actually. So I never do very well at this game. But this game is about 200 lines of Ruby code. The levels are defined as a text file, and so it's really, really easy to edit and hack and change to be what you want it to be. So that's Captain Ruby. There are some other examples. Let's go back. So that's Captain Ruby. I've written a couple of different gems myself that use GoSoo. One of them is called Little Brat. I wrote this originally for my kids when they were younger. They wanted to sit on my lap and type on the computer just like Dad. So I got a little 9-inch netbook, and I wrote this little gem intended to be running on Linux on the netbook. Gem install Little Brat. But it's a keyboard smasher, and what it does is it allows you to hit keys, and it will. That is not good. Sorry, I changed my system around, and I must have lost that. There are a bunch of different examples. What we'll do is we'll come back to this at the very end and kind of show the different games that you can run. I apologize for not having that. This is one of the problems with GoSoo, is sometimes it has a hard time installing. And I'm not entirely sure why I've got that. So anyways, we'll punt on that, and we'll come back and talk about that a little bit later. So there's a bunch of different games that we have. I wrote another game called Escape to RubyConf, which hopefully we'll be able to show at the end. I also have another game called Ruby Hop that is pretty fun, and I thought worked. Let's see if I have that installed. Yeah, here we go. I'm going to switch to I'm going to switch input so you can hear it. All right, there we go. So Ruby Hop is an attempt at like a Flappy Bird clone. And that, again, is about 200 lines of code. It's really not that much to understand. There's lots of different types of games that are possible. There's a competition called Let 'em Dare, where you build a game in 48 hours from scratch. So you build all your art assets, you build all your code within that 48 hours. GoSoo is a great option for that. Lots of Rubyists compete in Let 'em Dare. And there are a lot of different types of games that have come out of the GoSoo community because they're trying to be very creative. So all right, let's go ahead and start. All right, so I think the first question most people get is like, how do you write games in Ruby? Like, where do you start? What do you need to know in order to make these things happen on your computer? The first concept we're going to talk about is the game loop. The game loop is the thing that all games have. It's very similar to like Windows event loop, if you're familiar with that. And just very simply what it is, it's a loop that runs continually within your game. It will notify you when certain things happen. Every time through the game loop, it will call update. It'll let you know that it's time to update your game. So you're going to make little micro changes to your game, every time through the game loop, and then it's going to draw your game. So it's going to give you, prompt you to paint to the screen. It's also going to let you know when input happens. Whenever a player presses a button or depresses a button, it will let you know that all that happens within the game loop. This is the thing that GoSoo brings. It's written in C++. It's cross-platform so that you can use this abstraction for your system on all these different platforms. GoSoo implements this game loop within a window class. And so there's a bunch of different concepts. There's not a lot. It's actually a much smaller set of concepts than a lot of different game libraries, which is one of the reasons I like GoSoo so much, is because it's very minimalistic. Basically, what GoSoo gives you is it gives you a window class, gives you an image class, and then sample and song. We're going to talk about these classes first. There are a handful of others, but this is really all you need to know to make a complete game, and that's what we're going to start with. The window is where that game loop is implemented within GoSoo. So we're going to create a window instance, and that's going to be running our game loop. So let's go ahead and look at window. If we come over here to our browser, this is again the documentation for GoSoo. You can see GoSoo window has a handful of methods. It's really not that much. Apologize for scrolling, probably didn't see that. This is everything that we need to know to create a window. So let's go ahead and do that. I'm going to create a new directory. Let's call it Hello World. Okay. Oh, looks like it already exists. All right, so let's go ahead and let's start over. Let's pretend that we don't have this code here. So we're going to create a new hello world.rb file, okay? And the first thing we want to do is we want to require GoSoo, right? That's the thing that we need to do in order to get it. We're going to create a new class call it a Hello World game, and it is going to inherit from GoSoo window. Okay. The other thing we need to do is we need to create a new instance of Hello World game, and we need to call show on that. Okay. So let's go ahead and see if this works. Let's just go ahead and run Ruby hello world.rb and see what we get. All right, we've got wrong number of arguments and initialized. So let's go ahead and take a look back at what our initialize method takes on our window. And here we go. Here we have initialize. Right here, it takes a width, a height, and then a full screen option, and then also an update interval. So let's go ahead and provide that. The way I like to provide this information is I like to define an initialize method, and then I'm going to take width, and then height, so 800, 600, and then full screen equals false. And then inside, I'm just going to call super. If you call super without the parentheses, without the arguments, it will inherit whatever arguments were given to the initialize method. So I'm going to go ahead and do that. This allows me one simple place to change like the screen, the size of my window. Let's go ahead and call this again. And here we go. We've got a window, and it doesn't do anything for us yet. We want a hello world game. So let's go ahead and make a hello world game. One of the things we can do is we can use caption, and we can set the caption on the window. So let's go ahead and run that, run our game again. And as you can see up here in the menu bar, it says hello Ruby remote. Okay. One of the things I don't like about this example is that if I hit escape, I can't really close it. I have to click the close button, and that's kind of hard, especially when you've got a lot of other stuff going on. So what I want to do is I want to define that button down method that we saw before in the game loop illustration. And I want to just call close if I press down the escape. So if the ID, which is the argument given to the button down, equals GoSoo keyboard escape, okay, I just want to close. Let's go ahead and run that. And then now if I hit escape, it closes. So this is good. This is kind of what I want. This will make our demos a lot easier because I can bring them up and close them down a lot faster. Now, if we run this, we've got hello world. It's up here in the caption. I don't like this as much. I would like this to go away. I want hello world actually within the window of our game. So let's go ahead and make that happen. So what I want to do is instead of having this caption, I'm going to create an image instance variable, and I want just a text image. Now, I could open up Photoshop. I could create a new image that said what I want it to say, but we can actually have GoSoo do that for us. There's a method on image that will create a new image from text. So let's call GoSoo image from text. Now, from text is going to take a bunch of different arguments. Let's move back over here to our documentation. Let's go look at the image class. As you can see, here's from text. It is going to take the text, the line, and then the options. Okay. So it's in something I didn't expect. Let's go and try this. So we'll say, hello, Ruby remote. Okay. That was the text. And then we need a font. Oh, line height and options. Let's try it. Let's say 100, and let's see what we get. Down here, what we're going to do is we're going to define a draw method, and we're just going to say image, oops, our image variable, we're going to draw, and we're going to say, just draw it and give it zeros. We'll talk about what this means in a second. Yeah, I don't think that would work. So, I think that the documentation was wrong. I was looking at the wrong thing. What we actually need to do is give it a couple more values. We need to give it a font to use. Default font name and size. Let's see if this works. There we go. Hello Ruby Remote. So there's our hello world. We're drawing this text on the screen. We can continue to have the caption. Say self caption. Yeah, there we go. So our caption is still there, but now we've got an image in here. So this is great. So we've got our hello world out of the way. It works. Let's make this a little more interesting. I would like this hello world text to do something, to be a little more interesting, not just sit there. Well, actually, the first thing I want to make that centered on the window. So let's figure out how to make that centered on the window. Let's make this a little bit smaller so it makes the demo a little bit easier. So let's talk about what these coordinates here are doing for us. This is our X, Y, and Z coordinate. If you've done any web programming, you're familiar with CSS, this is the same thing. This is just where we want it positioned on our window. If we take a look here, this is our window here. Our coordinates in the upper left-hand corner are 0, 0. So X is 0, Y is 0 in the upper left-hand corner. The bottom right-hand corner is our full height and our full width. So since we have an 800 by 600 window, if we want our image to be in the very center, then we need to use 400 and 300, right? That's the same as height divided by 2 and width divided by 2, okay? So let's go ahead and do that. Like I said, we can go ahead and just say 400 and 300 and then 0 for our Z index, which is how close to the player that image is going to be drawn. If we run that, now our image is clipped off of the side. It's not all contained within our window. That's because right here in the very center of the window is where that point is as getting drawn. All right, so we can go ahead and change that. Let's say let's get that center point and then just move it back by the image.width, right? And then do the same thing, get that center point and then subtract the image.height. Okay, let's see if that works. That doesn't work again. Now we've just moved the image. Now the bottom right point of the image is centered, but the image isn't centered. So the way we can get around that is just dividing by 2. If we take the image width and divide it by 2, and the image height and divide it by 2, and we're using that center point on the screen, there we go. Now we're centered, right? Now we got that image centered. This brings up a really important part about writing games in Ruby, is that math is involved, right? And that's kind of a bummer sometimes because here you are, you're having a party, you're having a good time, and all of a sudden math shows up, right? And you're like, I thought I was done with you in school, but math is back. Math is here to stay and is an important part of making games. It doesn't have to be super complicated, but there is definitely some calculations involved. So what do we do to try and get around this? It's just something that we have to account for. We just have to be aware of. All right. We're doing calculations. One of the things that I would rather do is I would rather make calculations here within the update method instead of the draw method. The draw method is intended to be used just to print things to the screen. If we're going to do any sort of calculations, I'd rather have that happen in the update method to make use of the game loop. This is important when we've got a lot more complicated things going on in the game loop. So I'm just going to create an X variable, right? And I'm going to set it to that 400 minus the image width. And I'm going to make a Y variable and set it to that. And then we've also got like a Z. That's going to be 0. This 400 is kind of a magic variable. This is the same thing as width divided by 2. And this 300 is the same as height divided by 2. Okay. So then when we draw, we can just say at X, at Y, and at Z. And hopefully this doesn't change. Let's go ahead and run it again. Okay, so we're still good. So what we're doing is we're trying to make proper use of the game loop. Again, the game loop has a bunch of different callback methods that's going to call for us every time we go through the game loop. It's going to call update. It's going to call draw. It's going to let us know whenever a button is pushed or whether a button is depressed. Let's make this game a little more interesting. Not really doing anything. It's just sitting there. It's very static. So let's go ahead and make this this image, this hello image, let's make it move a little bit. So one of the things we can do is now that we've got our center point for X, let's go ahead and modify it just a little bit. We could be really trollish here and then just give it offset it by a random value. What that's going to do is it's going to make it jump around and be really chaotic, and that's not very nice. One thing we can do to make it a little softer, a little smoother, is we can use our math information and we can give it a sine wave. So we will do that is we call sine on our math constant and we give it time.now.2f. That will turn time into a float, call sine on that float, and then we can exaggerate that a little bit, I think maybe by 100. If we run that, now what we've got is every time the game loop goes through a loop, we're going to modify that position just a little bit. What that does is it moves that image on the screen back and forth ever so slightly. All right. We can also make it go up and down, and that's with the Y. So we'll say Y. Let's do cosine this time of time.now to float, and let's multiply that times 200. Okay. And now we've got this sort of elliptical kind of movement going on here because we're using two different waves. The cosine wave is modifying our Y coordinate, our up and down coordinate, and our sine wave is modifying our X coordinate. We can change this. Let's change this from cosine to tangent. And we have tangents. I have a good idea what's going to happen. It's just going to drop completely off and go back up. Okay. So this is how we create the illusion of movement within games. The game runs a loop. That loop is usually fixed to like 30 frames a second or 60 frames a second. Some games will run as many frames a second as they can. Other games try and run it in fixed. GoSoo runs a fixed game loop, so you can configure that. By default, it's once every 60 frames per second. But it will update the screen just like a movie to create that illusion of movement. Okay. All right. So now that we've conquered our math, it's not so scary. We want to see things and we want to hear things. It'd be nice to hear them as well. So let's do that. Now I don't have my sound, so I'm not finding it. There we go. I'm gonna get a waveform. This is a sound file. I'm just gonna drop it over here in my project. Okay. So what we'll do is we want to create a new sound object, and we'll do that by calling GoSoo sound.new, and we're going to pass in self and create a wave. Let's go ahead and just make sure that this works. Oh, sorry, it's not sound, it's sample. All right. Did I not spell it correctly? Let's make sure that I got the right name. And then let's go ahead and change into that directory. Okay, there we go. So now I've got this new sound object, but I'm not really doing anything with it. Let's go ahead and change that. Let's say that every time we press the X button, we want to go ahead and play that sound. So what we'll do is we'll say sound.play if ID equals GoSoo keyboard X. I'm going to switch the audio input so that you can hopefully hear what this is going to do. All right, so every time I press the X key, hopefully you heard that sound. That's a sound. There's two different classes for dealing with audio. There's the sample, which we just did here, and then there's also a song object, and they're just slightly different. They serve different purposes. The sample object is intended to be played over and over and over again. Maybe it's some sort of effect sound. You know, every time a character walks or something, you're going to play the footsteps sound. Maybe you can have lots of these different samples playing at the same time. So it's intended to have multiple times, to play them multiple times. A song object, on the other hand, is more intended for background music. And so it's going to use different set of system resources. And that's why there's a difference there. I don't know. I don't have any MP3s. There you go. Here's a Code Monkey Saves the World. Let's pull in like a Skull Crusher song. Okay. So we've got our sound. Let's go ahead and create a song. That's going to be a GoSoo song object. I'm going to pass in self, and then pressure.mp3. And then when we create our game, we're just going to go ahead and call song.play, as it's going to always be playing. So let's go ahead and switch our audio, and hopefully you can hear this again. So that's how we play songs in the background. We usually do it when we initialize our game. We could actually here in our input, we could call song.pause if the ID equals like maybe GoSoo keyboard space. So we can affect, since we have this object, we can affect it, we can call methods on it, but that's how it's intended to be. So what we've shown so far, real quick here, in about a half hour is we can create a window, we can draw images to that window, we can take input from the user, and we can play audio as well. So we got visuals, audio, and input. This is the basis of creating a game. Let's go ahead and let's change our example. Let's create a sprite. Let's go to our slides as well. All right, so we talked about song and sample. Hopefully what you came away with is that this was easy. And it's actually really, really fun. It's really great to be able to change a couple lines of code and affect what the screen is doing. I like it. The feedback loop is really, really tight. And I really enjoy this. So hopefully you enjoy it as well. There's one thing that you may have heard, a term you may have heard from different game developers or just from people who enjoy games, and that term is sprite. And what is a sprite? A sprite is just a region of the screen that is going to be, updated. It's usually a character. It could be like a background image if you've got a tree that waves in the wind or something. That's all going to be controlled by this concept of a sprite. But it's just a small piece that renders something to the screen, and you can add some behavior to that. So there's not a sprite class that comes out of the box within GoSoo, but we're going to create one ourselves. There's another term within this kind of world when dealing with sprites, and that term is a sprite sheet. And a sprite sheet is an image that contains a series of smaller images, and this sprite sheet, when gone through sequentially, shows an animation cycle for my little Super Ruby character here, right? And so he's going to start on the upper left-hand corner and then move right and then down row by row. And this character then just moves his feet, moves his arms, flaps his arms a little bit, and go ahead and walks across the screen. So let's go ahead and build that. Again, GoSoo doesn't have this out of the box, but it's pretty easy to create. So we're going to come in here. We're going to create a new file. Call it spritegame.rb. And we're going to go through the exact same step that we went through on our first Hello World game. We're going to require GoSoo. We're going to create a class that's called Sprite Game. It's going to inherit from GoSoo window. Oh man, typing in front of people is not my strong suit. Okay. After we've created or defined our class, we're going to create a new instance of it and call show on it. We need an initializer that's going to take a width of 800, a height of 600, and a full screen of false. I'll super on that. We're going to create a update method, and we're going to create a draw method. Okay. And then we're also going to create that button down method, and we're going to close if that is escape. Okay. Let's go ahead and run this game. And all right, so our boilerplate here is correct. So what we want to do is we want to create this little character. We want to paint him to the screen. To do that, let's go ahead and create a sprite class. Okay. And one of the things that uh, one of the concerns that you might have seen in our Hello World example here is that whenever we call GoSoo image or sample or song, we're always passing in self. That's because one of the things about GoSoo is that there can only be one instance of the GoSoo window created. Right now, that's going to be our sprite game. Um, in order to draw to the screen or to play audio to the system, we need to have a handle to that window object. So whenever we create a new instance of the sprite class, we need to pass in that window object as well. So I'm going to go ahead and create an initializer that's going to take a window, and we're just going to go ahead and save that in an instance variable. Okay. I'm also going to call I'm going to create an update method similar to what we have on our window, and I'm going to I'm going to create a draw method also similar to our window draw. And the reason for that is what I eventually want to happen is I want to create a sprite by passing in self. And then whenever the window updates, whenever the game loop updates, I just want to call update on our sprite. And then whenever our game loop calls draw, I want to call draw on our sprite. Now we could be passing in window to the update and draw, but I prefer to do it here in our constructor. All right, so now we've got this container. This is really no different than what we had before when we have an image, but we can go ahead and let's take this image here and let's draw this instead. Okay, so what we'll do is we'll get our image. That'll be a GoSoo image.new called from window, and so player.png. On update, we're not really going to do anything, but on draw, we're going to say image.draw. Let's just give it the 0 coordinates for now and see if we can get this to run. Right, there it is. So what we've done is we've created a sprite class within our game loop window object. We are instantiating that sprite object, and now we're calling update and we're calling draw on it. It doesn't do anything. It doesn't really respond to changes, however. But we can hit escape and close it. So we're moving forward. One of the things I would really love to do is I would love to be able to move our character back and forth. So I'm going to go ahead and create X, which is going to be window.width divided by 2, and Y, which is going to be window.height divided by 2. And then just so that we're right in the center again. And then on update, I want it to move. Now, one of the things we're doing on our window is whenever we push down on a button, we're going to move it. So there's a couple of ways we could do. We could create some new methods here on Sprite, like a def move left, right? Which will just take our X and subtract 5 from that position. Same thing, we can create a move right, which will move it to the right here. And then on button down, right, we could say sprite.move left if we're pressing the left key. And same thing, you could say we're going to move right if we're going to move right. So if we do it this way, I'm find this window, right game 31. Oh, sorry. There. So now if we move left or right, it's not really moving anything. Why is that? Oh, we're not using our new coordinates. All right, let's try this one more time. So now if I press my left or right, it's not really moving. Hmm. Oh, we're not looking for that ID argument, not doing the comparison correctly. All right, so there we go. So now every time I click left or I click right, the character is going to move. But if I press and hold, it doesn't move every game loop. It only moves every time the button is pressed. And that's not as good. So there's a couple of things I'd like to change. One, I'd like to get the character to be actually in the very center of the screen. And two, I'd like to be able to just press and hold and have it update. So what we can do is we'll take that, that X and Y coordinate, and we'll do the same thing. We'll decrement it by the image.width divided by 2 and image.height divided by 2. That will get us in the center. Okay, and then instead of doing it on button down, I think we should check it with an update. So I'm just going to get rid of this code here. On update, what I think we should do, there's actually another method on our window object. We can check to see if a button is pressed, right? So we can say move left if window button down, and then pass it our GoSoo keyboard left. Okay. Same thing, we can move right if we're moving right. Go ahead and see if that works. There we go. So now as I press and hold, the character moves. I don't have to press each individual time. The game loop is going to take care of checking if the button is pressed and do it that way. So we're not so much caring about when the button is pressed down. It's just every time through the game loop, we're looking for if the image is pressed or if the button is pressed. All right. All right, there you go. So the other thing I would really love to do here is I would love to have that image kind of rotate. So if we're moving left, I'd like the character to face left, or if moving right, I'd like the character to face right. So let's just make a direction. We'll make that right at the moment. So here, whenever we're going to move left, we're going to set that direction equals left. Otherwise, when we move right, it's going to be right. And now here in our draw method, we can say if direction equals right, then let's just go ahead and draw it as normal. Else, we want to flip the image in some way, right? So if we run this right now, we're not really doing anything. We do this now, we're not doing anything when we go left. So when I go left, he disappears, or the character disappears. And when I push right, the character appears. That's because the character is not being drawn when facing left. We need to figure out how to make this character face the other way. And we can do that by manipulating the image. Let's go back to our class. Let's look at image. And let's look at the draw method. There is a bunch of arguments that we're not using. We've got our X and Y and our Z. We've also got scale X and scale Y. Also a color argument and then a mode. The things we're going to look at here are the scale X and scale Y. What this is going to do for us is we can scale that image. So if we just take this, and when we're facing left, let's just give it a like a 2 and a 2, okay? And then run it. When we go right, we get the movement we expect. When we go left, our character is suddenly twice as big. And so these numbers reflect how this image is going to be manipulated. One of the things we can do is we can pass it a -1 for our x value. And what this will do is it will actually flip and mirror the image for us. So now when we move right, we're correct. When we go left, that image is going to be flipped on that, that origin axis, which gives them kind of like a hopping movement. To get rid of that, one of the things we can do is we can take that x coordinate and then we can add the image.width value to it. And so that way, whenever the character moves left, is not flipping on that axis, character is just turning the other way. Okay? So this is a little trick that we can use using the same image, mirroring it, and having it face both ways. This is good. What we'd really like to do, though, is we'd really like to use this movement sprite sheet to do that for us. Unfortunately, we don't have the time for that. So I'm just going to go ahead and open up this other file, and we'll kind of look at what that looks like. Here, what we've got is we've got two different images here. One is we're going to load this idle sprite sheet, which is when the character is not moving. The other is this moving sprite sheet. And so now we're going to keep track of not only the direction that they're moving, so direction right, but we're also keeping track of moving, which is going to be true or false. And so when we call update, we're going to set it to moving as false. If we're pressing a button, we're going to go ahead and flip that moving to be true. If we're pressing left, we're going to go left. If we're pressing right, we're going to go right. And then when we draw, we're going to pull out the frame that we're going to draw. And then we're either going to draw it right or we're going to draw it left. And there you go. So let's go ahead and show how that looks. So here's our character. Here's the idle animation. When we press and hold right, he's going to move. Press and hold left, the character is going to move left. The character's direction is being flipped, being rotated, mirrored, left and right. It's the same sprite sheet moving left and right. Other games, they can potentially have a different move left animation versus a move right animation. But there you go. So here is a very simple sprite class that we are instantiating. If we look here at the game really hasn't changed at all. It's our same game. We're creating our game. We have our initialize. We create the sprite. We're going to close on button down, escape. We update the sprite every time the game loop updates, and we draw the sprite every time the game loop draws. And that's it. So from a game development perspective, our window is very simple. A lot of the complexity of the logic is encapsulated within our game objects. And that's what a sprite gives us. There are a lot of other options as well, which we are unfortunately not going to be able to get to. Let's go back to our slides. There's an effect called parallax, which is really fun as well. Let's go ahead and show that demo. So here is our same sprite class that we were working on earlier. And what we have is we have two different background images, and those images are going to move at slightly different speeds along with our image. That's going to give the illusion of depth. And so here, this character is on an airport tarmac, moving right or left, moves the two different images in two different speeds. And that gives the illusion of depth, right? This is a very 2D kind of styled approach. The thing that I really want to call out here is that I think this looks pretty well. Again, this is developer artwork, but this is a pretty smooth running game. It's not very interesting yet, but all of the bones are there. Everything that we need in order to create a really compelling experience for players is right here within this GoSoo library. And all it takes is very minimal amount of effort from the developer standpoint to put all these pieces together. So the thing I'd like to end on here is that if you're at a conference, or if you're at a user group meeting, or you're at a hack fest, take time, write a game, and have lots and lots of fun. I love Ruby. I love the Ruby community. I love just writing code and writing games and making fun games is a terrific way to spend your time to learn more about programming, and also to have a great experience with other people. So thank you very much. My time is up. My name is Mike Moore. I am Blamage online, and I guess if you have any questions, I can take them until everything is gone. Chuck, what do I do?
We've got about 2 minutes.
All right. Any questions?
People are typing furiously.
How would you compare GoSoo to some of the other game engines like Cocoa 2D and Unity? The GoSoo is much more minimal compared to a lot of the other ones. I prefer it, actually. I don't really. I enjoy creating my own sprite classes. I don't want to take someone else's approach to that. So for me, this is all about experimentation and creativity. And so by having a minimalistic library, it gives me more opportunity to create different abstractions. But it's a Ruby library, and so you're kind of constrained to where you can run Ruby. There are ways of packaging up a Ruby executable and all of your code into an app that can be downloaded on Mac and Windows and Linux. And so you can actually have people install apps that are written in Ruby that will play games. But it doesn't give you quite the performance as the other libraries, but conceptually it's a lot higher level concepts, and so you're not dealing with the details as much. Let's scroll.
Do you typically need to mess with tick speed in update methods?
No, I don't. The GoSoo library, the GoSoo window object will call, update, and draw for you, so you just respond to that. So it's using the callback method. One of the things you could do in update is take the current time and store that in an instance variable, so that way all of your calculations are using the exact same time value. But I don't really have a need for that very often.
All right, one last question. Realistically, how much of a performance hit do you see from using Ruby to implement the logic, at least in your experience? Obviously, this is dependent on the game.
Right. So if you look at like Ruby Hop, you're not going to hear the audio because it's going through my speakers. And open up Activity Monitor. I'm running a 4-year-old computer, 4.5-year-old actually. So let's see. Ruby. My CPU running this game is 6%, 3%. So it's really performant. I don't see a lot of drop frames very often. Obviously the more your game does, the more resources you need to consume, the more you're going to pay that Ruby runtime penalty. But there are a lot of really sophisticated games written in Ruby that perform really great on current hardware. So unless you're doing the new Doom, you can write a lot, especially the independent games. You're going to do a game all by yourself or with a very small team. I think you can get an awful long way using GoSoo. And you've got OpenGL access and everything else if you want to do 3D as well. So, okay. Thank you very much for letting me present, Chuck. I appreciate it. And if you have any questions, get at me on Twitter or online, and we're always happy to pair with people and make more games. Let's have more fun.
All right, thanks, Mike. We're gonna disappear now for a minute or two while we get Dave set up, and then we'll hear from Dave Thomas. Let's code like it's 1969.